Let us move to our next session, Site Reliability Engineering and the role of QA engineer. Today, we have Sanjeewa Alwis as our speaker. Sanjeewa is the Director SRE Cloud at PSN Sri Lanka and is an expert on site reliability engineering and DevOps. He is also a technology evangelist, leader, entrepreneur, and writer in his field. Hello, Sanjeeva. A very good evening to you, and welcome to Dev Day 2021. The virtual screen is all yours.
Thank you very much, and thank you. I need to specially mention the Hickory team and this wonderful event and the sponsors. This has been wonderful, evening. I believe it will be. Hope you guys can hear me well.
Yes, Sanjay.
Okay, cool, wonderful. So I'm going to discuss a few things about site reliability engineering and how it relates to the QA. So we have been discussing about site reliability engineering in many forums and sharing ideas and viewpoints of what we believe in and also how what site reliability engineering can be implemented on the organizations. So today I'm going to share a few slides as well to assist my presentation, but I will be not taking long time in explaining these details. But hope you can see my screen.
Yes, Sanjay.
Yeah. Okay. Cool. So can you see the slide number 1, or because I don't see a view from my end here with the.
Yeah, we can see the slide number.
Okay, cool. Right. So thank you for my introduction. I will not spend time on introducing myself, but I'll be discussing more about how this QA role will evolve within the site reliability engineering space. So as you all know, a little bit of background towards the site reliability engineering. Site reliability engineering was something, the term was coined basically through Google, but this was an evolution. Now, when the software engineering teams and the QA teams started to transform into agile practices, the other side of the house, which is the operations, were in a little bit of a trouble because the business objectives were very much aligned with the agile model. It was very much aligned with the engineering, so product engineering teams and with QA engineers. But the operations were having a different objectives and different visions. So basically, the business demanded faster releases. They wanted to quickly features going out to the products, and they cannot wait. Even though here and there, if they face a bug, that doesn't matter. In some cases, they wanted to release the new feature which was not available to anybody. So rather than using a feature that is fully tested, bug free, the business wanted to have more. Faster deliveries, where even though they were tolerating few here and there, one or two bugs, but if we can release the features as soon as possible. So that was pretty much achieved through agile model, where if you are properly implementing agile, at least at the end of the sprint you will have something to be released. So the quick releases, the release pipeline was getting speed up. So when this happens on the operations side, the operations teams were having the traditional mindset where the operations teams were more focused on the stability. So when more and more releases coming in their way, more and more they experience that the systems are going down or the systems are experiencing stability issues. So when you are facing that, when you are facing such troubles in the stability wise or the availability wise, the operations engineers resisted the faster releases. So they kind of resisted into it. So then there was a transformation, a paradigm shift has to happen within the operations teams, the traditional operation teams like database teams or application support teams, Linux, Windows engineers. Those are the traditional support teams or the traditional operations teams. So those teams, they have to have a transformation. So that transformation is pretty much triggered this site reliability engineering. So the site reliability engineering teams have started to pop up, and they were supporting the agile vision. They were supporting the faster releases, and their mindset was different. So when the site reliability engineering concepts come into play, it started to absorb those concepts into the engineering side as well. So that is where the site reliability engineering started to cover the entire product life cycle, from the requirement gathering to the final feature delivery. Up until the entire thing, the site reliability engineering concepts starts to cover the entire process. So then the teams like Google, Facebook, the big giants, they have started implementing concepts similar to site reliability engineering, and those were changing the dynamics, changing the game rapidly. So this is something came up within last 3 to maybe 5 to 7 years. So now we are in an era where we are looking for more of full stack engineers. Now we don't really see a much difference between a product team. A product team might involve QA engineers, developers, the operations people, but they all drive towards the same goal because of this site reliability engineering concepts. So now with this, there was a question: does SRE replaces the QA role, or this whole transformation of becoming full stack engineers? When I'm using the full stack engineering word here, it is not the context the traditional context. The traditional context of full stack engineer means the front end development and the back end development. But here I'm using the full stack engineering with a concept of covering the entire thing, including operations, maybe including security, cyber application security. So I'm trying to cover the entire concept using this full stack engineering, not just the front end and the back end. So when engineers are responsible for the entire thing, when they become responsible for the entire thing as a whole, as a feature, as a team, you are responsible for the entire thing, not just a one part of it. The traditional silos were broken down. The traditional silos where I do only the coding and the QA does the QA part, and the operations engineer is responsible for putting it to the production and then running it production. That is not my responsibility. And if an incident comes up, again, the operations engineer has to fix it. If it is only a bug fix or a code level issue, then it will come to me as a software engineer. We had those barriers or walls, I would say, between these organizations. So these things started to disappear. So when these barriers started to disappear, the whole process I was talking about previously, the complete software engineering life cycle, the product development life cycle, becomes a one team's responsibility, and the each and everyone started to contribute to everything. So this is a tricky situation. So when we are getting into a situation like this, does it replaces QA? That is something where we will discuss. So the quick answer is no. It will empower the QA role, but we have to understand and implement it properly so that the QA role, the software engineering role, the operations role, everything will be empowered through this site reliability engineering concepts. Because as I said before, site reliability engineering is not only covering the operation side now. Now it becomes a complete product end-to-end product development life cycle, part of the complete end-to-end product life cycle. So software site reliability engineering becomes this entire thing now. So now with this, I wanted to explain a little bit about the basic concepts of site reliability engineering. So I would call them like, SLA, SLI, SLO, and error budgets. This creates a fundamental thinking or a fundamental way of approaching the site reliability engineering. So let's get to know what these SLAs, SLIs, and SLOs are. Now, if I take an example, if we are developing a e-commerce website, if you are developing an e-commerce website, you will have a shopping cart in the e-commerce website. So now this shopping cart, we want to develop it. Now then, as a product manager, we might be coming up with an SLO. A product engineer may come with an SLO, service level objective, saying that this, whenever I want to add a certain good into the shopping cart, the transaction has to happen within 30 milliseconds. Let's say if that is he comes up, that is the target that he comes up. So he comes up with a target saying, when we want to load the item into the shopping cart, the entire transaction has to happen within 30 seconds. So that is his SLO. He will add another part to that SLO. He will say this transaction has to be loaded. When I click add to shopping cart, it has to be completed within 30 seconds, and it has to happen 99.998 times. So that means out of 1,000 transactions, within only two transactions, you can go beyond 30 milliseconds. The remaining time, it has to load within the 30 seconds. Remaining transactions, only 2 transactions can go above the 30-second barrier. So that is the SLO that he comes up with. Now, when somebody comes up with an SLO in a site reliability engineering, it will be something like this. So this can be for many areas. Some might come up with another SLO saying, for our product, the shopping cart has to be up and running 99.98 times, 90% of the time. Then shopping cart has to be up and running. That is again a different SLO from the previous SLO. Previous SLO was more of a response time latency related SLO. But the secondary one that I told was more of a availability SLO, which means within in a given year, in a given time, 99.98 times, this shopping cart has to be up and running. So we will have how much, like, within I think very small time for the entire year that this can go down in minutes. This can go down in a small time only. All the remaining time it has to up and running. So this is what the SLO is. So SLOs are what we defined as a product. Now, when the SLOs are defining, we need to define SLIs. SLIs means service level indicators. Now, what are the service level indicators? The service level indicators are that assist the SLOs. Now, for example, coming back to my previous example, where if a certain good needs to be added into the shopping cart within 30 seconds, there can be 3 or 4 transactions that has to happen. For example, a database call must have to be generated whether the product is available in the stores. That's the one call. Likewise, there are few transactions. It can be RESTful or whatever transactions has to happen in order to achieve that goal. So those, let's say, if there are 5 functions that has to execute to get this work done, then these 5 functions as a whole has to run within or below 30 milliseconds in order to achieve our final goal. So that is the SLI. So SLI means what are the each and every transaction, each and every component of this business transaction, how much that it is getting loaded. For example, how much time will it take for that business transaction to execute, and within that business transaction, if there's a database call, for that database call, how much time will it take to execute that database call? Maybe it can be like 10 milliseconds because the entire thing has to run within 30 milliseconds. So the underlying components, underlying small transactions might have to run within, altogether within 30 milliseconds. As an example, it can be 10 milliseconds. So those are the SLIs. So SLI gives an indication whether are we matching this SLOs. So this is a basic concept. I wanted to explain this in a site reliability engineering because in site reliability, if we are implementing site reliability engineering practices properly, it is not just a name change for us operations team. It is not just a name change. You have to actually define the SLIs and SLOs for your product. So once you define the SLOs, then you get an error budget. That means you get some variant or some leverage that you can play with. Now again, going back to a previous example, let's say if your shopping cart has to be up and running for 99.98 times, then for a year you will have about, I think, sorry if I didn't calculate it properly, I think it's about 20 minutes. For a year, I think it's about 20 minutes. So let's say it's 20 minutes. So for a year, 20 minutes, if the system goes down, there is no issue because with our product, with our customers, we have agreed to this SLO. So there is 20 minutes that we have for the entire year that we don't care if this application goes down or not. So if your application availability SLO is 95%, then it's, you have plenty of time where you can play with. Within that year, you can play with that time. So there you can, you can let, if even sometimes if you feel there can be some bugs which are not tested, you might want to push the code into the production environment. You are not afraid to take the challenge because there is an area that you can play. There's a time that you can play. For that year, your SLO is still met. You have an error budget where you can play with it. In my previous example, let's say now the business transaction, which I was talking about, loading the shopping cart within 30 milliseconds. So for every million transactions, there is 200 leverage that you can go wrong. So if 200 transactions go wrong, that is fine. You are okay with it because you have agreed with your customer that this is okay. So this 200 you can play. Now up until that you reach that 200 limit, you can do experiments to your system. You can take risks. So these SLAs and SLOs are defined based on the products, products business nature. If it is a financial transaction, or if it is a product where it requires, high precision, then your SLOs are very high. It will go 99.999, so many nines. But when, when it is getting closer to 100, you'll have to invest more to, achieve it. So it will involve cost because you will have to have a DR systems that are up and running, real-time DR. The data, there are so many investments that you have to make in order to, increase your application's availability. But there are some applications, you can get away. Now, for example, if it is a news site, and it may not be a mission critical application. So you might be get away with a 98% of availability SLO, and you have 2% of error budget that you can play with. So that is this difference between the SLIs and SLO and error budgets. So error budget is something where you can play with. Now, when you are introducing proper SREs into an organization, you will get this error budget. When you get this error budget, what will happen is, so this is a slide where I put few details which I explained before. So about SLIs, SLOs, and SLA is more of an agreement that we will have with a customer. It's a contract with a customer based on the SLOs. So there isn't much essentially a bigger difference between that. But SLIs and SLOs are the ones that we need to understand carefully. So pretty much I explained it with examples. I'll share the deck after this presentation for the completeness. So let me move forward. Now, I was explaining that you will have an error budget to play with. Now, when you have an error budget to play with, it creates some sort of a vicious cycle, because then you might be start forgetting the QA practices. Sometimes because there is an error budget, you have time to play, you have things to play. If your application is up and application can only go down 1 hour per the entire year. Let's say from January, February, when you are making releases, if application has not gone down, you have like a 1 hour remaining. 1 hour error budget is remaining with you. So you start to play with that one. You take risks. Sometimes when the business requirements are urgent, you might put releases without considering a lot, and you might take the risks. So in real world, when in day-to-day life, you must be thinking what Sanjeev is talking about. We are 1 hour downtime. Is it real? Like, for example, some of our applications have been gone down for 3 or 4 days. So what you're talking about? So then it's actually some applications. If it has gone down 3 or 4 days, that means that application owners, the product owners, the business owners are accepting that the SLO for that application availability is that much. If they want to increase that availability more, then there has to be an investment. It is not just, there are some efficiencies you can do, improvements you can do, but again, it will need an investment. It will need time. It will need money to make that application is, up and running, and not having 2 or 3 days of downtimes. So I'm explaining more about advanced application which has implemented SRE correctly, and a time critical, mission critical application which only can tolerate about 1 hour or 2 hours of downtime for the entire year. So I'm talking about such a high advanced application. So even in these scenarios, if you have ever done manage or develop financial applications like stock exchange applications or higher banking applications, then you will have to achieve these targets. It's like 1 hour downtime will cost millions and billions for the financial organization. So those are very critical applications. So even when you have like a leverage when you are implementing SRE, you will have this error budget, you will have the leverage, you will have time to play. So you start missing the QA practices. So this becomes a vicious cycle. And what will happen is when you start missing the QA practices, then your error budget is getting reduced. Your application uptime is getting impacted. So when this getting impacted, another SRE principle will come into play. That is, if your error budget is getting utilized, and if your error budget is getting down, then you have to go for code freezes. You have to stop the releases because your objective is to achieve this SLO. And in order to achieve this SLO, you cannot have buggy releases going on to the production. So you'll have to come and fix that issue. So when you are trying to do that, when the code freezes are getting introduced into the product, then it impacts to the business. The feature requests are so fast that the product engineers, they want to have the features going up faster than you expect. So so then it is getting impacted. Now the pressure is coming back to the software engineering team again to see to optimize this. Now only most of the organization, the vicious cycle ends here. Now only that they start realizing how important the QA practices that we need to implement. So without coming into this situation from the beginning itself, we have to find a ways to introduce the QA testing practices that will help to measure the SLIs and SLOs. So that is very important. Now, for example, now we have to design tests in the SRE world that it will look for these SLIs. Your test, especially the performance test, has to be implemented in a way that it will measure that the SLIs are not going down. In your perf environments or in your pre-production environments, you can run the perf tests and see whether if this applications, if this code, if this new release goes down to the production, will it impact the SLI? So as a QA engineer, you need to be absolutely sure that one thing is that there is bug free, it is bug free is like it's something that you cannot achieve in the real world. I mean, at least it is all the possible bugs have been identified, but also the most important, the secondary part, which is that this release, will it impact the SLI? Will it impact the SLOs? Will this release increase the database call of if this release increase the database call, then let's say if previously the database call was 10 milliseconds and this new release will make it to 20 milliseconds, then when you add the other relevant transactions, it can go beyond the previous expectation that we had. Our total SLO that we wanted to have was 30 milliseconds. So it can go beyond that 30 milliseconds SLO. So as a QA engineer, your responsibility is very much now tied with the application performance monitoring tools. There are so many New Relic, AppDynamics, Datadog. So none of them are sponsoring as far as I know. So I just mentioned the names without without in a particular order, just names that came to my mind. But there are so many application performance monitoring tools that are out there. So these application performance monitoring tool, some of them are very costly, some of them are very budget friendly. So these are the things that you need to consider as a QA engineer. Now your role is not only to see whether the feature is working fine, but also the non-functional requirements are there, so that this new release will not make impact to any of the SLOs. So you have to design the tests in order to see what are those different SLOs that we have agreed, and whether those SLOs will get impacted due to this release. So this is a different approach in designing tests. So as I listed in the slide, it says the find tests that looks at these metrics. These should be tests to look at the effect code has on the look at the effect code has on the metrics. Consider the maximum possible impact the test could show the code having on each metrics. So these specific SLOs and SLIs, you have to be very careful and find out them, and then design the tests and measure them. And then you have to have a pretty good idea as a QA engineer before this release goes down that this will not impact any of the SLOs or SLAs that we have agreed. And also you can consider the error budget that is available. So based on that error budget also, your test may be thorough. You might have to do a thorough analysis or a deep test in order to see exactly can we protect this error budget for the remainder of this year, business year, likewise. So the designing this tests will be very crucial in this SRE world. So your objectives of designing tests will be drastically different. You have to start aligning to the SRE principles. Another SRE principle that you will need to align with is the observability. So observability is a key aspect. Observability is the next generation term that we use for monitoring. Previously, monitoring was just looking at a screen and looking at the screen and see whether a certain metrics goes beyond a threshold. But that monitoring era is gone. Now, if you look at, there can be millions of metrics. But for example, imagine a cluster with 10 servers in a production environment. How many metrics that we can derive out of that cluster? For that 10 servers, CPU is measured in every server. So that means 10 metrics of CPU. And memory is measured, 10 metrics of memory for that service. Storage, 10 metrics of storage. If it is a Linux system, if it has a file systems, 2 or 3 file systems, again 40 metrics. Imagine likewise when you think and add more and more metrics, it will be millions of metrics even for a small 10 server cluster. But does this, I mean, can we look at this? Can we look at and can we take a judgment whether this application is up and running, whether it's fine or not? Because your threshold may be 80% for the CPU, but at 60% of CPU and 40% of or 50% of memory usage might trigger an incident, which cannot be measured from the metrics, because metrics measured only one thing. So how can you measure these things? Again, coming back to the SLIs, you have to measure the SLIs. Your observability is based on SLI. What are the critical business transactions that we have agreed with our product, saying that we will be developing this, and what are the underlying components that we have to measure to achieve that SLO? So that is something where a QA engineer has to focus on. So as QA engineer's role has shifted to production in this SRE world. A QA engineer is not just someone who's playing around in the pre-production environment. He is someone who's looking at production. He is someone who takes decision based on the production environment data. And he is someone who's measuring the production performance of an application, a production availability, production environment availability of an application, and brings that into the pre-production environments and tests that in the pre-production environment and make sure that within the pre-production environments, we have identified ways that and we have made sure that this application is fit for the purpose to be run in production environments. So observability is a key concept when it comes to QA engineers. So those are the things I think in this QA role has to be changed. The traditional QA role will drastically change in the SRE world, and it will take a different form. So the last item which I want to discuss is the automation. SRE is all about automation. Reducing toil or reducing the day-to-day activities that we do manually, we have to get it out of the system and we have to automate it. So the QA role has become significantly important. Modern day of SRE engineers have to be very savvy in automation. Because with SRE, we'll introduce CI/CD pipelines. We want push button releases, canary releases, where the code, when the code is pushed into the production, into the software repository, when the code is merged and when the code is automatically the tests has to start running. It can be unit tests or whatever the tests you name it, the automatical deployments of the code and the tests has to be automated. So that's very important in the SRE world. So the QA engineer's role become an automation engineer. So the traditional QA role will disappear very soon. And I think in future, a QA engineer is another, I would call another form of a software engineer. He himself writes codes. He himself writes test cases. So the traditional, manual exploratory testing, you might do it here and there just to see how the look and feel of a product. But these manual tests will be automated heavily, and it is being automated in many areas. So if you are coming from a traditional environment, these are the improvements that you can introduce. So, sometimes when you are working for a product company, when you are tight on a when you are working for a client, the client may require certain things to be implemented sooner. The features needs to go out faster. Then you really don't have time to invest on this QA automation or CI/CD pipelines. You just have to get the production, the feature up and running somehow and give it to production environment. But this creates a long-term impact, because the next time also there is nothing that you have automated. the things that you have did previously, you have to do it again manually for the next release also. So if you want to actually achieve, if you are a project manager, if you want to achieve the profit from that release, then initially investing in automation will result a long term. Then it'll give you results in the long term basis, because for the next third change request that comes in, I don't know how much you want to bill for how many hours you want to bill, but actually if you have done the automation properly, you won't actually spend a lot of time there, whether how much you bill or not to the client. So so then your time will be not wasted. You can properly use that. So this is something where we can think of and implement and empower the QA engineers role in this SRE world, so that SREs drive a critical component in the SRE atmosphere. So that with that, I wanted to wind down. And if there are any questions, I'd happy to take that. I'm on LinkedIn, so if you want to reach out, that is also fine. Please reach out to me directly. If not, we can ask the questions here as well.
Thank you very much, Sanjeewa. So we have a few questions.
Okay.
Let's go ahead and take those now. So
Okay.
just another reminder for everyone, please be sure to type your questions in the Q&A section if you haven't already. So the first question is, can you please explain a bit about IoT and how it will help for future testing?
IoT.
Yes.
So this IoT in the sense Internet of Things, or in some other meaning?
Internet of Things, I'm assuming. Possibly maybe the person would clarify the question if at all possible. Do you have anything to mention, Sanjeewa, or shall we?
So it's a tricky thing. I mean, like IoT involves with a lot of hardware related software development activities. So the question is basically, if my memory is correct, it says how the IoT will impact the future testing.
Yes, please explain a bit about IoT and how it will help for future testing.
So
that's what the question is asking here.
Yeah. So it impacts to a certain certain part of the software engineering world. Now, for example, the software world, which involves a lot of hardware related components, and it'll involve. Now, for example, when you are building let's say a smart home, when you are building a smart home, and you have to have necessarily associated with a software that is to operate that system. So for those systems, when you are using Internet of Things, it'll impact, it'll add value. But in our traditional the software engineering space that we were talking about, in a traditional software engineering sense, I wouldn't think that it will impact in a big way, because these are like two concepts that are going parallel. Now I think I don't need to explain IoT, right? Based on that question.
Yeah, no, that's fine, Sanjeev. I think the questioner got a good answer. Otherwise, he or she can, I guess, always reach out to you later on.
Okay.
So we'll move on to the next question. Can you please explain about the difference between DevOps and SRE?
Yeah, that's a good question. So traditionally this term has been used interchangeably. In Sri Lanka also there are DevOps engineers, and I personally, my viewpoint is I'm not against using the DevOps engineer in their title. But the book says, the theorists involved in this says, DevOps is a practice. It is not a role. Site reliability engineering is the implementation of that practice. It's the difference. So DevOps is all the concepts associated in the site reliability engineering, but it is not a role. It is a way of working. When you say DevOps, it involves QA, security, software engineering, operations. How all of these are working together is the DevOps. It's the concepts around it. How we can bring the silos down and how we can merge them into a one team working for a one goal. All the concepts associated with the DevOps, associated with this is actually within the DevOps. And site reliability engineer is someone who actually implements that in the ground. So it doesn't have much difference between these two. But in Sri Lanka, there are some roles as a DevOps engineer. So I personally don't mind using that as for an engineer even. But Google used the word site reliability engineering for their DevOps engineer. So then only this site reliability engineering came up. And then Google introduced other concepts like SLI and SLO and SLAs. So with that, site reliability engineering took a little bit of a, it's a branch of a DevOps.
Okay, thanks so much, Sanjeewa. I think this next question is also pretty much you have answered. While I'll just ask it if there's anything further you need to comment on this. So the question is, if we take Sri Lanka, we have DevOps jobs are available, but how about the opportunity for site reliability engineer? Is it new to Sri Lankans?
Yeah, again, it is you have to develop pretty much the very similar skill set to become a SRE engineer or a DevOps engineer. So site reliability engineering is something that creates a lot of job opportunities around the world. It's a demanding skill, very much in demand these days across Sri Lanka and even across Europe and everywhere. So experienced DevOps engineer has a lot of job opportunities. So don't worry about the naming conventions, whether it goes as DevOps engineer or SRE engineer. If you are fluent in a either private cloud or a public cloud platform, it can be a data center based private cloud platform or a public cloud platform, AWS, Azure, or something like that. If you are familiar with that, one of that at least, and if you are familiar with CI/CD pipelines, implementing CI/CD pipelines, there are different tools that you can use. It can be, how to implement a CI/CD pipeline. So if you are familiar with that, and if you are familiar with, maybe a modern day software applications, pretty much microservices. So these microservices running on as pods or as containers. So like container technologies, maybe Docker or Kubernetes, if you're familiar with those technologies, I think that will give you a good edge in this to become an SRE engineer, or in some company it is called as DevOps engineer.
Thank you so much, Sanjeev. So again, this next question also similar, but I'll just put it to you anyways. How QA testers become SRE? What are the things we should know as SRE?
Again, the same answer. Understand of the SRE concepts like SLOs, SLIs, and SLAs. And in Sri Lanka, I rarely see people have actually implement these SLAs, SLOs, and SLIs. But globally, it is very much implemented, because SRE is not just a software engineer, not just a role who does the code cloud deployments. Or SRE is not just an engineer who do deployments, who install the Kubernetes clusters, or you use the EKS clusters. It is not just that who implements a CI/CD pipeline. Not just that. It involves the business acumen as well by implementing SLOs and SLIs and SLAs. But in Sri Lanka, I rarely see the SRE team implements and works towards the SRE culture using SLOs and SLIs. But still, Nevertheless, you have to have that understanding of that concept, SRE concepts, theory behind it. And then the technology-wise, again, the things that I explained before, it's a CI/CD pipeline. It can be a GitLab or Jenkins, whatever the Go CD or whatever the CI/CD pipeline you want to have. And then the cloud platform, basic knowledge of a cloud platform, private cloud or public cloud. And that is, other than that, the rest is pretty much specific to the application. But in modern day, since every application is moving towards the microservices architecture, the knowledge of how microservices are deployed in production environment like Kubernetes or Docker, those technologies are very important modern.
Thank you very much, Sanjeev. So next question, what are the frequent tools used by site reliability engineers?
Site reliability engineers are using a lot of tools. For observability, site reliability engineers has to use like APMs. I discussed about this during my discussion as well. Application performance monitoring tools. It gives you like how much time it takes to a business transaction to be loaded, because in this world it is very important to understand the business transaction. So that is observability. So when it comes to observability, the real user monitoring like Google Analytics type of application, the application performance monitoring, and the underlying infrastructure monitoring tools. If it is AWS CloudWatch, whatever it is, these underlying infrastructure monitoring tools, those things, the monitoring observability wise, you have to be familiarized. And CI/CD, I mentioned few technologies before. And infrastructure as a code, if it is on AWS, either CloudFormation or CDK, if it is a general infrastructure as a code tools, then it will be like more of Ansible or Terraform. And the software repository technologies, those are very important. Those are tools that site reliability engineers are using day in, day out. Unlike a software engineer, site reliability engineer may use many tools or many technologies because his role is very broad.
Thank you so much. So next question. Based on your experience, when was the good time to implement the SRE concepts in a project? Based on your experience, what was the best time to implement the SRE concepts in a project?
It's a very good question. I think we can implement at any stage, but our approach will be different. Now, if you are implementing at the beginning, that is very easy. Now, because if you have done anything, if the code is not there, if it is a brand new code, then while the software engineers start sketching the architecture of the software, parallelly with that discussions, you can start sketching how the release pipeline will work for this product. Are we going to use canary deployments? How is our cloud architecture that we are going to use to host this application? Because when the software architecture is getting defined, we will know, there will be a set of whether this will be a microservice based product or this will be a traditional product. So based on that, we can design our infrastructure. If it is microservices based, are we going for a Kubernetes EKS or type of a platform to host it? Or if it is a traditional one, are we going to use it in a traditional cloud environment? Or if it is a data center that we have, then how we are going to architecture our data center? And then what is the software practice that we are going to do? Initially, it is very easy for you to define, right? Because then you can go and define your CI/CD pipeline, and you can work with the software engineering and together, and then define, let's say, our CI/CD pipeline will work like this, and the software developers has to commit the code in this way, and then the code will check out, and the build script will automatically run in this way using a Jenkins or whatever it is. Automatic build scripts will run every time you check in a code, and then build test will run against that build, like that, you can jot down and you can define that thing at the beginning. That's very easy. And then if product is already a mature product, already production, it's running in production, if that is already there, then you can use some like a I would say metrics based maturity model. You can define set of levels you can achieve. For example, for the first level, you will only define certain things to be achieved. Build script will be automated, and after every check-in, the build script will run. That can be the stage one. I mean, not only that, but with that, another few criterias, you can say this is our stage one of SRE transformation. This is the stage one. Then the stage two, you develop, you create the CI/CD pipeline. I'm just giving example. You can define this the way you want, but in this example, I'm saying the second step can be the deployments are all automated. That's the maturity model level 2. Like that, you can define level 1, 2, 3, 4. Like that, you can define the levels, and then you can achieve those levels one by one. Because unlike in the fresh project, here it will be difficult. You'll have to change the people's mindset, change the practices. You have to put a lot of effort. Now that you have to have a maturity model, where you take step by step. You achieve the level 1 of SRE transformation first, and then once everybody is happy with it, you enjoy the benefit of it, then you go to the next level. Each and every level, you can carefully plan what are the things that we are going to achieve. That requires a professional help, expert help in defining those maturity model. That is where if nobody has done that before in the organization, then the DevOps consultancy will come into play in those type of scenarios.
Thank you, Sanjeev. So there are some more questions, but unfortunately, since we are running out of time, we'll wrap up for today. But before you wind up, Sanjeev, is there anything else that you would like to say or like to comment on?
One thing I would say is this transformation is inevitable now. We are going to low code or no code platforms. So coding or operations or QA will no longer be a job role in future. So if there are people who wants to grow another 10 years or 20 years of a long career here, I think based on my advice, the industry is changing so fast. There are low code, no code platforms coming in. You will need very few people to do things. So the industry is transforming to be from a generalist from a specialist to generalist. So my advice is everybody to try to become a generalist, where you know a little bit about cloud, you know a little bit about software engineering, you can write a code, you can design a front end, you can manage the cloud environment. You become a generalist. The specialist era of specialist is fading away. Where I remember when I started, people who were, for example, some technologies were very precious. Now, at one point, I was like one of the WebLogic experts, and only me or one guy was in the entire Sri Lanka. So we were like, very special skills, WebLogic experts. But now there is nothing like that. The specialization is not there. So that more generalization becomes, because tools enables us to do that. There are so many tools. Within a week, if you spend your mind to it, you might have a basic IT knowledge, but you can develop your own software and implement it, and you can start bringing the cloud, start bringing the traffic into the product within 1 week. There are tools like that. So, software as a service there, infrastructure as a service there, platforms as a service tool there. Now, when I started to install a Redis cluster, we took, sometimes a day, because to troubleshoot, there are so many issues. The network is not properly configured. To install Oracle rack, we took 3 or 4 days. It was a cumbersome process. We managed the hardware itself, connecting the entire private IPs and all that. But now you can just click a button and provision a cluster for you. So the tools are enabling us. And so we wanted to become more of a generalist where we know everything. So I think that is where the industry is heading towards. So my little bit of advice is we all have to, march towards that.
All right. Thank you so much, Sanjeewa. With that, we'll conclude our session for today. We are truly humbled and honored that you gave this presentation today. Thank you very much for the most insightful session.
Thank you.